All right, now in question 3, we are supposed to create a linear queue to store 100 integers, and we have to declare the queue. Head pointer, assign an appropriate initial value, and tail pointer. Okay. Head pointer points to the first number stored in the queue, and the tail pointer points to the next free space. Okay, so this is, as always, the most important part of the question. So when we have a queue, we have, let's say, 10, 15, 19, and 30 here. So head will be pointing to 10, let's say, and whatever value that will go after 30, so tail would be pointing at that index. Okay, it will always be pointing to the next available space. So this is the most important part. So in the question they're saying declare the variables, okay, and the array. So we'll do that. So q is equal to empty initially, and then store 100 integers. Okay, so they're saying declare the global array queue, and then in the next part they're asking us to enqueue the values. Okay, so they've not us to initialize it anywhere in part A and B, so we can just do it on our own. So let's assign zeros in all these places. So for 0 or I in range 100, I believe, yes, 100 values. Okay, and then the head pointer, let's call it just head, or lowercase head would be initially -1, and it points to the first number stored in the queue, because initially there would be no element stored in the queue, so it should be at -1, and then tail would be pointing to the next available space, which would be 0, because that in case there is no value, it would still get pointed to the next available space, which would be index 0. That is where the next value will go. All right, then in the next part they're saying that you have to write function for enqueue, so define enqueue, and here we put in the item. Okay, takes an integer and stores it in the queue. It returns true if it was done correctly, successfully, and otherwise false. So head, tail, and we have the queue here. Okay, and then we are just going to check if the tail is greater than or equal to 100, right? Because it's supposed to point to the next available space. So if it exceeds the value of 100 or becomes equal to 100, that means that the queue is full. So we will simply return false. If that is not the case, I'll simply store the value at the tail index, and then I'll increment the tail by 1, and then I'll return true like this. Okay, simple. Then they're saying main program, use the enqueue function to store the numbers 1 to 20 in the queue. Okay, so we just have to use a loop here in the main program. So main, and then the program should output successful if all the numbers have been successfully enqueued, and unsuccessful otherwise. In ascending numerical order, the number should output successful. Okay. Okay, so we are going to run the loop from 1 to 21 times, because they have said to store 1 to 20 numbers. So 21 will not be included because of the range function. So we get the response. The response would either be true or false. So if the response is true, then we will print that it was successful. And otherwise, if the response was not that, so I'll just print unsuccessful like this. And they are saying, yeah, that's pretty much it. So if we run it, it is adding all the values because there are only 20 values and we have a total of 100 items in the array. Yeah. Then we move on to the next part. So they're saying the following iterative pseudocode calculates the total of all the values stored in the queue. Rewrite this function as a recursive using program code. Okay. All right, so what is happening in this question? So we are just supposed to calculate the total of all the values. So they're starting in the pseudocode, they're starting from start minus one, which is whatever the number that we have input, and then it is going all the way till the head pointer, and it says step minus one. Okay, we didn't use the head. Okay, so we use the head variable instead. And then we are supposed to increment the value of the q by 1. Okay, so start minus 1 to head pointer step minus 1. The reason we are start minus 1 is because we are starting to store the values here from the index 1 and from the value 1, and the indices start from 0. So, or we can directly start from 0, and we are incrementing the value of the current q element into the total, and we keep on doing this, and once the loop ends we are going to return the total. Also, this is going in the reverse direction because there is a step minus 1 here. So whatever the start of the value is, let's say it's 10, head pointer is maybe set to 1. So it says 10, then 9, then 8, then 7. So it's going to print the q values in reverse. So 10, 9, 8, 7, 6, etc. So we just have to do this recursively now. Okay, now to do this recursively, we simply have to write the base case and the recursive case. So the base case would be that start would eventually reach 0, right? That is when the for loop should end. So that would be a recursive case. So if start becomes equal to 0 at any point, then we are going to return the q value that was stored at the start. Okay, so for this we should have the q here. I think I made one above, so we'll copy it. Let's bring it here. This is just a comment here. Okay, so this is the value, and this is where the tail is pointing, this is where the head is pointing. So what I'm doing is, if the start becomes equal to 0, so let's say the start is set to, these would be the indices, so 0, 1, 2, and 3. Maybe the start is set to 3 here. Okay, like this, the start is set to 3. So every time what we're doing is we are decrementing the value, and we are going to that specific index. So when we have start, it goes to start 3 minus 1, it becomes 2. So it will pick this value, it will add it into the next value, into the next value until we get 0. So when we get 0, we are supposed to return this value because this would be the last calculation. So that is what I'm doing. Whatever the value is being pointed at index 0, just return that value. Otherwise, if that is not the case, we will return. Okay, so what do we return? So in this case, we are going to do this. So in the recursive call, we are going to subtract 1 from it every time. So let's say if the start was 3 here. So since 3 is not equal to 0, eventually it has to become 2. Then 2 will get copied here. So 2 is not equal to 0, so this has to become 1. That is why we have to reduce it every time. So it eventually reaches the base case. This is the first part. So this is the base case. Base case. Okay. So until start does not converge to 0, this recursive call will keep on happening, and that is why we're subtracting 1 from here. Okay, plus q start. So
Why
what?
is the condition?
So when we set the start to, let's say, 3 here again, so at the third index, we start from here. So we see, is 3 equal to 0? No. So 3 minus 1 becomes 2. And before we make this recursive call, we'll store the value of 3 in this recursive call. Okay, so let's actually trace this. So it would be q index 3 plus recursive output of call to 2. Okay, then we do the call to 2. So it's not equal to 0. So this would become 1. So this would be then, and this here would be 2. So it would be q index 2 plus recursive output of call to 1. Then we go to 1. 1 is not equal to 0. Then 1 minus 1 becomes 0 here. And then this remains 1. So this recursive call would be q index 1 plus 0. Now when this 0 passes here into this line 26, since it's equal to 0, this is the base case, it's going to return you the value at the start index. So the start index, it has 10. So this recursive call here would return you 10. Then this 10 plus 0 gets returned to recursive call 1, and then the value at index 2 is returned. So we had value at, this was supposed to be the final recursive call, so this would return you the value which was 10. Yes, so 10 would be returned here. Then we have the recursive call 1 which will return you the value 15, so this would become 25. Then recursive value, it will return 19, so 19 plus 25, whatever the answer is, and then this gets returned here, so 19 plus 25, and then finally the value at index 3, whatever the value is, 30, and this gets replaced here, and we get the total output 30 plus 19 plus 25. So this is how it's going to do the recursive calls. I'm going to modify this and bring back the values.
Why are we returning?
So let's just do this, the last part, so print.
Can you just